I think that I went through section 2.2 too quickly for some of you. And when I asked you things like, are we okay? Can we move on? I see nods, and that's kind of why I do it, but you gotta be a little bit more vocal and say, no, could we see another one? Because if you don't tell me that you're not sure, then it's hard for me to know. And the reason why I know this is that I got some questions from people about homework, and it was pretty clear to me that they hadn't quite figured out what to do. So there are two things I want to go over from section 2.2, hopefully make them a bit clearer. The first one, I do know it's totally my fault. I went and said, oh, I'll let you figure out how you do Desmos. What I didn't realize is, what I should have realized anyway, is that it's not that easy to do Desmos if you've never seen it in your life before. So the first thing I'm going to show you is how to do a piecewise function. Piecewise function using Desmos. So imagine you got a question where you're being asked to do a sketch of this, and then from the sketch, you're then going to decide for what values of A does the limit exist? That's typically the question. I off the top of my head, oh, I'm glad I wrote it down. It's questions 8 and 9. So if you're interested, this is our first thing. So you may want to, since this is right at the start of the video, if you may want to just go back and look at it again and pause it and play about with Desmos. But right now, I'm just going to go through it. So suppose with this piecewise function where the function takes the values 3x plus 4 when x is less than 1. It takes the values of x squared when it's between -1 and 2. And it takes the value of this fraction when x is greater than 2. So we call these piecewise functions. Now, essentially what you do are these three guys. In Desmos, you will write y equals, I call them curly brackets, this guy, a colon, and then the first equation. So do you know it's like you switch places. You put that first, colon, and then that. And then the middle one, that's this guy here, you put an x squared. And then for the greater than, that's the last one, you put in the fraction. So I'm now going to go over and kind of show you me doing that so you can get an idea of what it looks like. So here's Desmos. And the first function, right? So we do our curly brackets, which are next to the letter P. And we do x less than -1, colon, and we do 3x add 4. Now, do you see that red line? That's this guy. And I should finish with my little curly brackets. Right? So I've done 1/3 of the graph. Then I'll hit enter. And the second one was x squared. So I'll type in its formula, which is x squared. No, I won't. I'll do my little curly bracket first. And then I will do -1 less than or equal to x less than or equal to 2. And then colon. And after you've done all that, then you can put the x squared in. So it's kind of back to front and upside down. And got to be careful where you put your brackets. There we go. Right, do you see the blue guy? That's the middle piece. Now, this piecewise function had 3 pieces to it. And the last one is what you use when x is greater than 2. And then you do a colon. And the function is, and I did it again, didn't I? Curly brackets. Then I do x greater than 2. Then I do my colon. And I've got 4 divided by a bracket, x add 2, close the brackets, squared, and that's that funny little green guy. And there's my curly brackets. And darn it, this thing's pretty nickety, isn't it? There's my little curly brackets. Right, so if I just adjust it a little bit, maybe zoom in a little bit more. A little bit too much, there we go. There, can you see that the colors don't matter, but it kind of helped me. Can you see the piecewise function there, right? Now, when they ask you at the end of sketch it, and the only reason you are going to sketch it is so if you can detect, is there any place where an overall limit's not going to work? Would you agree the only problem you're going to have is at 2? Right? Right? Isn't everywhere else on the function the overall limit's going to exist, right? It's just a normal curve. So the only place where there's a kind of problem is at x equals 2, which is here. And so let me return now to our working and say, okay, then that's the picture, right? That's the picture I just gave. For what intervals of values, or write down the intervals of values for which the limit as x tends to a of f of x exists. Well, it exists everywhere except 2. So if you want to tell people you can use any number you like except 2, this is what it looks like in interval notation, which is what they're expecting. A curve bracket means you can't use it. So negative infinity to 2, but you can't use 2. The union symbol, curve bracket 2 comma infinity. Now, if I nip back and go somewhere where like, that one, I think. Hold on a moment. I'm just getting WebAssign loaded up. I thought I'd done it, but evidently I haven't. Okay. So just trying to find an equivalent question. Just to show you the buttons that you would press on WebAssign and to do infinity and to do some of the other things. I think most people know how that works, but not everyone has seen them, so. Okay, why are you not letting me hit anything in? Oh, I can't do it. Will you trust me there's a bracket button? I just can't make it happen on the one I've got. So little curve bracket, minus infinity to the union symbol, which is not the capital letter U. There's actually a symbol called the union. I think it's down in a submenu called symbols to infinity. So that's how you use Desmos to sketch a piecewise function. So are we good? Does anybody want to see another one? Are we definitely good this time? Okay. Right. The second, oh, that's not yet, that's for after this. The second thing I want to go over in section 2.2 is how to evaluate a limit. Using a table of values. So basically, how do you evaluate a limit using a table? And there are going to be 3 situations. I want to do one of each. We're going to do a question where the limit exists, right? The limit is a number. So that's my first situation. Let's show you what that might look like. Let's do the limit as x tends to 0 of sine x over x. And you're going to do a table of values, and at the end you're going to say that's equal to 1, or it's equal to 0, or it's whatever it is. So I'm pretty sure mine's is set up correctly, but just in case it's not. Oh, I just had an idea. Give me a second. Come on. This might or might not work. Let me check it. No, it didn't work. Okay. No, I guess my computer is not going to be my friend today. Right. So if you want to find this guy, make sure that you are in radians and just keep it in radians for the next 10 weeks. I'm going to set up a table. And here I'm going to put the expression that we're trying to find the limit of. And since I'm interested in the limit tends to 0, I need to pick some numbers that are close to 0, and I need to pick some numbers that are a little bit bigger than it and a little bit less than it, just to be in the safe side. So I'm going to take 0.01 and 0.1. And the other side, I'm going to be positive 0.1 and 0.1. That's a good combination. And go to y equals. Type in the expression that you want to work with. In this case, it's sine x divided by x. Go second table setup. And as long as you make this guy here, right, as long as that's highlighted as asked, you never need to go into table setup again. Then we just go second table. I'll hit the delete button to get rid of old answers from other questions. And negative 0.1, negative 0.01, 0.01, and finally 0.1. And if I put these numbers in, I've got 0.998, 0.999.9. I've rounded off a little bit, but that's fine. 0.998. Would you agree as you go towards the middle that 1 is a reasonable answer for what that limit is homing in? Would you agree these numbers are just going to get closer and closer to 1? You see that? That's at 0.998, that's at 0.999. If it did another number, couldn't it be 0.999, 17 more 9s and an 8? It could be getting closer and closer. So that's an example of a limit when it's a number, right? When you do the table, the guys on the left meet up with the guys on the right, and they're homing in on one number. Does that make sense? Right. So second guy, second situation. The limit does not exist. So an example of that would be the limit as x, no reason why it's always 0, but it is in this question at least. The limit as x tends to 0 of x, the square root of 1 plus x to the negative 2. Okay. I'm going to do a table, at least this side is going to look pretty much exactly the same. And this guy here. So I'm going to choose a number like negative 0.1, and then maybe negative 0.1, and then positive 0.01, and finally just 0.1. Now, since I've already set up table setup, all I need to do this time is write down this guy in y1. So that's going to be an x times the square root of 1 plus x to the power of. You got to be careful. You probably don't need these brackets to put in the negative 2. But I always kind of, if I'm not sure if I need a bracket there or not, I err on the side of safety. I just always give it one, right? Because you won't cause damage by putting in a bracket that you didn't need, but you could cause damage. If you ever done order of calculations where you really needed a bracket and you didn't put one in and you were getting weird answers because of that, that's kind of the argument. So if you're not sure, do you need one, put one in, as I have here. Now I've already done the table setup, so I'm not going to do that, and I'm now going to go back to here. And isn't that nice? That's more than I was expecting. Haven't I already got these numbers set up? Right. So I don't need to retype them. So I'm going to have the answer negative 1.005 and then negative 1. And then I get positive 1 and positive 1.005. Now, as you merge towards the middle, do you see that on one side the answer is negative 1, but if you come in towards 0 on the other side, isn't the answer plus 1? Do you see that? Now, what's going to happen if they try and meet in the middle? Well, they're never going to meet. Would you agree? One goes up and the other goes down. So that's essentially what the limit does not exist looks like. Right? When you do a table of values, the numbers are not converging as they are here to approximately 1. On one side, the numbers are getting closer to 1, and the other side, as you get, you move downwards, they get closer to -1. And then the third situation is one where the limit is infinite. So an example of that would be the limit as x tends to, 4 of 2 over x minus 4 squared. At y equals, take that guy in. So it's going to be 2 divided by a bracket, x take away 4, close the brackets, and square. Oops, didn't hit square. Square. That's set up, so I'll just go here. Now, my table is going to be a little bit different because I want 4. I'm trying to find the limit as it gets closer to 4. I'm going to be choosing some numbers slightly smaller than 4 and then some numbers slightly bigger than 4. So I'm just going to do 3.9 and then a little bit closer to 4, 3.99. I can't really put 4 in because it wouldn't work on this one anyway, but I'll do a 4.01, which is dead close to 4, and then someday just a little bit further away. So there's my little 4 guy. I can, I've already set the thing up, done all the things I need, so I should go 3.9, 3.99, 4.01, and 4.1. If you look at the kind of the pattern that you have here, it's 200. As you get closer to 4, the next answer is 20,000. Would you agree that's getting just bigger and bigger and bigger? That means plus infinity. If you do the 4.01, it's massive as well. And if you do 4.1, it's still kind of big. And so as you go towards that, can you see both of those are getting, if I wasn't sure, couldn't I put a 3.999 in just to be sure? Just do that since it's here. Yeah. 2e6 just means 2 million, right? It just doesn't have enough room. 2e6 means 2 times 10 to the 6. It means 2 million. So if they merge in the middle and they merge in a way that they're just going to get bigger and bigger forever, that's what a plus infinity looks like. So you could have a limit that's a number. You could have a limit that doesn't exist, or you could have a limit that's infinity, right? And these are all done essentially the same way, right? Table of values.
Is the x minus 4 supposed to be squared?
It better be. Did I not do that?
Well, I mean, I'm not sure. It just isn't on the chart.
Oh, that's just because I didn't write it. There we go. But
Okay, I just want to make sure.
Yeah, it is in my calculation, and the table is right. Okay. Are we comfortable now about the table of values? Because I feel I shot through that quicker than I should have. Are we good? Do you want to see any more? This is your last chance. Okay. Yeah, I feel a little bit better, and hopefully those people who were having some issues with the homework, life will be a little bit clearer for you. Okay, we're on to 2, 3. The good news is that we have done all the homework that you need is 5.1 and 5.2. So for this Sunday, you only need to complete up to section 5.2, and the test that you will get, which will appear on Friday sometime, Friday afternoon, evening, that's only going to contain questions from section 2, 1 and 2 as well. So we're going to get started in section 2.3 today. We might finish it tomorrow, but I doubt it. It doesn't matter if we do or don't, because section 2.3 is not due this week anyway. But I would suggest to you, if you want to make your life easy, that you do some of the questions, right? You do as much as you know how to do, so that next week, won't you have less homework to worry about? So to make your life easier, I would suggest you do that. So we are looking at how do you find the limit of a function, right? And we're talking about how you do it algebraically. So we're not going to do tables of values or plug it in my calculator or sketch it or anything else. We're going to find the limit of a function using algebra, using various laws. And we talked about this yesterday, so we're kind of recapping. There's a technique called brute force, which you'll use for questions 2 and 3. There's a method called factor and cancel, which you'll use for questions 4 to 8. There's a method called the conjugate method, which you'll use from 9 to 15. And then I've just added some special cases. That's questions that don't really fit into any of these 3 categories. So let's start with the first method for finding the limit of a function algebraically. The first method is called brute force. So how does that work? Well, essentially, let's show you an example of how it happens. Suppose I was being asked to find the limit as x tends to 5 of x squared plus 25 over x plus 5. In brute force, what you do is you just find the value of this expression when x is 5. Well, if I just basically chuck it in, replace it, we get that, great. That's 25 plus another 25, and the bottom's 10. So that's 50 over 10. And so the answer is 5. Do you see in that question then, the limit is really just the value of the expression, right? And that's one of the laws of limits. And it says, look, if you can plug in the number and you can get an answer, then that answer is the limit, right? It's almost trivial, but that's what it says. So you might, for instance, get a question, this is again is brute force, where x tends to -1, and it's x plus 1 squared plus 7 over 2x plus 5. Well, if I plug in -1 for x, this expression becomes this guy here. That plus that is nothing, so nothing squared is nothing. Nothing plus 7 is 7. And 2 times -1 is -2. If you add 5 to that, you get 3. And the answer is 7/3. And that's what we want. We don't want you to call that 2.666 or anything. We're talking exact values here. Now, that does mean that sometimes your answer will look pretty strange. It's okay to have the square root of 7 as your answer, right? You could plug something in and that's what you get. It's okay to get the square root of 7 plus 1 over e squared. That is the answer we're expecting. So you do not turn whatever fraction or weird expression that you might get when you plug the number in, you don't turn it into a decimal, you just leave it alone. And that's the exact value. Looking at faces, that's best. That's why I like videos, so I can see you. I don't think this has caused much problems. From the faces I can see, you're just saying, yeah, I can evaluate anything, can't I? If it works, it's a limit. So I'm going to move on unless someone would like another question. And by the way, it's totally okay to ask. Some people don't like asking questions because they think, well, people will think I'm dumb. I'm going to ask a stupid question or so. You're old enough to be confident to know that there's no such thing as a dumb question. There's only dumb answers, and that's what I do, right? So there's no dumb questions as far as I'm concerned. And the chances are that if you have an issue, I mean, people have done it today where, are you sure that, should that have had a square? You know, things like that. Tell me about it, right? I like that because it's wrong and we want to fix it. But right now I'm assuming that this is good. So I'm moving. So that basically just gets you by questions 2 and 3. So you're not going to get a lot of them because, you know, that's really not that much algebra. It's more, you know, calculating things. So now we're going to move on to this new group of questions. And the method is called factor and cancel. And I'm going to look at the homework, see if I can pick one of their questions. What the heck's that doing over there? Get over here. Vanessa, why do I keep talking to myself?
What do you mean?
I keep mumbling to myself as if someone else is here.
Because you're looking for intelligent conversation.
You got it. It's the only way to have an intelligent conversation. You can't remember that one? I thought that was a good one. Okay, so moving on then. Let's find an example where factor and cancel would work. So this is the limit as x tends to -3 of x squared plus 3x all over x squared take away 6x take away 27. Now, I think a natural question you might ask yourself is, how do you know this one is a factor and cancel? Couldn't it just be a brute force question? Right? And the answer is it could have been. So how do you tell? You plug in -3 and you see what you've got. Now, you can either do this in your head or you can do it in a bit of scratch paper. Let me show you what that would look like. If I did plug in -3 here, I would get -3 squared plus 3 lots of -3. That's the top bit. On the bottom, I would get -3 squared, take away 6 times -3, take away 27. That guy is 9, that guy is -9. So the top becomes 9 take away 9. That guy is 9. 2 negatives make that guy a positive 18 and take away 27. Do you see that what we end up with is 0 over 0? Got that? We even have a name for when that happens. So just in case you hear it being mentioned anywhere. This is called indeterminate form. So if you ever get a 0 divided by 0 kind of question, right? Nobody knows what 0, no, by the way, it's not 1, right? 0 divided by 0 is not necessarily 1, it could be anything. So that's how I know that this one is not brute force. Now, if it ain't brute force, it's factor and cancel or it's conjugate. So while we're at it, for the most part, except for these exceptions, how do I know when it's going to be this method or this other one that I haven't shown you how to do yet? If you see a square root, right? If there's a square root of x, a square root of x plus 4, right? That kind of thing, right? A square root with x's in it and maybe +2s and whatever. If you ever see that, you're going to use the conjugate method, right? Would you agree this doesn't have any square roots in it? That's why I know it's a factor and cancel. So for the 3 main methods, plug in the number. If it works, you're done. That's brute force. If you get 0 over 0 and there's no square roots involved, it's a factor and cancel. If you get a 0 over 0 and there is a square root involved, you're going to use this method here called the conjugate method. So let's return to this fella. I'm going to change colors because I've got an awful lot of blue here. So it's going to be the limit as x tends to -3. And I like things that have names that give you a clue. The name here is factor and cancel. So what you're going to do is you're going to take the numerator, the top, and factor it. And you're going to take the denominator and factor it. So that's the first stage, factor. So far, so good. Okay. What can you do about the top? What would the factor be on the top expression here?
You factor in x.
I would do that. And you would get an x add 3. You all comfortable with that? Taking out a common factor of x. Now, the next one, oh, you poor souls. Do you know those poor people who had to fight their way through factoring trinomials, quadratics? I mean, you spent forever and a day in Math 99 doing them, remember? Hundreds of the little darlings. And you probably were hoping, that's it. I don't need to worry about them. I'm never going to see them again. Bad news, you're going to see them all the way through your calculus life. Factoring is just one of those things. Now, this is a quadratic, also called a trinomial. Since this is x squared, I have x and x. Since the number is negative, that tells me it's a plus and a minus. Can anybody tell me the factors of this one?
Negative
3,
9
negative
and
9.
+3.
I had a +3 and a -9, and both of you are correct. Now, here's a little clue for you. Because this method ends up almost always involving a cancel, like factor and cancel, it should. If I know that x +3 is in the top, aren't I pretty much guaranteed that one of the two guys in the bottom has to be x +3? Doesn't that make your factoring a little bit easier, especially if that number's like 81 or 120, where there's so many combinations you could spend a fair chunk of time trying to get it. So try and think of, oh, well, if I know that's there, I know one of these two is there. And I guess once you're committed to that, isn't that one kind of obvious what's left? So it does make your factoring a little bit easier. And that's the factoring part. And now it has a second piece to its name, and it's called and cancel. And do you notice that this factor is allowed to cancel that factor? And what happens then is that our fella, our limit, has now been altered to an equivalent fraction. In this case, that fraction. Seem reasonable? But this time, I can plug in -3 and I won't get that horrible 0 over 0. So that's what I do to finish. -3 on the top, -3 take away 9 on the bottom, -3 on the top, -12 on the bottom. The whole thing ends up being quarter. So the limit as x tends to -3 of this horrible fraction is 1/4. Now that's not an estimate, that is the exact limit, right? Now, I wouldn't normally do this. I might do it in a test because I would want to be a little bit more, to be sure that I've done it right. But I'm going to try and prove to you, roughly prove to you anyway, that that actually works. So I'm going to go and I'm going to type this guy into my calculator. So it's x squared, add 3x, close the brackets, divided by, start a new bracket and type all this in. Okay, I've already got my table set up, so I'm not worried about that. I'm going to go into second table now and just rub out the old fellas. Now, aren't we interested in the limit as x tends to -3? Okay. Now, I'm not doing the whole table of values in 4 numbers. All I'm going to do is pick a number that's dead close to -3, and I hope the answer comes out to something that's dead close to 1/4, right? That's my check, right? It's not a perfect thing, but it's a check. So here goes. I'm going to choose x is -3.1, 2, 3 zeros and a 1. Would you agree that's darn close to -3? So when I hit enter, I want to see an answer that's dead close to 0.25. I know I've done it right. If that answer had been, I don't know, 0.5, that means that this should have been a half. Couldn't I then figure out what's going on? Right. Okay, why is that a half? It should be a half. Why have I got a quarter? Oh God, I forgot a 2. Right, and you can fix it. That kind of thing. Some of you might be thinking, hey, I don't need all this factoring. I could just do this quick check thing, you know, and do it that way. Well, you could do it in your homework. I would call that kind of semi-chain, right? Because you're not doing it, you know, the algebraic way that they wanted to. And I wouldn't know, and you probably get good homework grades. But I'll tell you what will happen. When you hit the midterm and the final, and I ask you to do this question, you are not allowed to just write down equals a quarter. Because when I ask you a question, I don't want to know the answer is a quarter. I don't really care it's a quarter. I want you to show me the math that proves it's a quarter. So I'm interested in working and showing me how you got the result. I'm not necessarily, in fact, if you screwed this up and you got the answer a half, but you were using this method, you'd get 80% of the points, even although your answer was wrong. Because I'm looking for the method, right? The proof that that's what it is. So don't get into that bad habit, because if you just do this shortcut and don't bother about doing it, what's going to happen when you get this question in midterm, right? I don't know how to do it. I used to cheat. And that's not going to help anybody in the long run. So I'm telling you that right now. Good piece of advice, I think. Factor and cancel. Go method. Pick another one. They tend to be, as you can expect, polynomials, cubes, things like that. Try this fella. Double checking here. Yeah, okay. There we go. Can we just skip the part where I checked that it wasn't, you know, that I couldn't just do it by brute force, right? And go right into, okay, we need to factor and cancel then. I'll take any volunteer that feels comfortable enough to factor either the top and the bottom, whatever one you want. Tell me one of them, what the factors would be. Go for one of them, top or bottom, whatever one you feel good at.
The bottom is x plus 5 times x minus 2.
Agreed. Now, if you're not very comfortable with factoring, maybe you should spend a couple of hours sometime in the next few days, just, you know, looking it up online, you know, reminding you the methods that you can use, the techniques to factor. Okay, the top one I've been a bit sneaky with. X cubed minus 4x. I'm going to do it over here in a little bit of scratch paper. Okay. Looking at x cubed minus 4x, is there any common factor that you can suck out of that expression?
Well, obviously the
X.
x.
I would take out an x. Now, if you take out an x, you're going to be left with x squared minus 4. Now, if I look at that and I look at that, I know it ain't working, right? There isn't anything common yet. And so I have to look at this again and say, oh, wait a minute. X squared minus 4 can also be factored. Isn't x squared minus 4 a difference of 2 squares? And so, anybody want to tell me what that would factor out as then?
X minus 2, x plus 2.
Agreed. Right, So if you're a little bit rusty, and I can understand why, who knows the last time you had to factor something, it could have been a fair amount of time, right? So we have an x, we have an x plus 2, and we have an x minus 2. Isn't that a good sign that we've probably factored it correctly? What tells you in this expression? What tells you that you've probably done it right?
Two of the terms cancel.
Right. So if I factor the top out and I factor the bottom out, but nobody cancelled, wouldn't that be a sign that, oh, maybe it was x plus 5 and x minus 2, not x minus 5x? Well, that one would have cancelled as well, right? But, you know, maybe I factored one of them wrong, right? And you should look at it. So we factored, we've now cancelled as well. So we have the limit as x tends to 2 of x over x plus 2 all over x plus 5. And once you've done the cancelling, all you should need to do now is the brute force part. Plug in 2 for x. 2 add 2 is 4, 2 4s is 8, 2 add 5 is 7. Your answer is 8 7th. And I'm not going to do it, but couldn't I do my little calculator trick to check it? And I should get a decimal that's pretty close to 8 7ths, which is about 1.13 roughly, I think. Is factoring cancel okay? Seems like a method you could handle. One last one. Well, one last one I intend to do, but that doesn't mean I can't do more. But one last one I want to do, because it's just a little bit different. And it's a version of question 8. And you can just trust me that if you plug in 0, you get indeterminate form, right? You get 0 over 0. So I know it has to factor. But what makes this question different from the other two is that I wouldn't try and factor this expression. Technically you could, but I'm not going to factor that expression. What I'm going to do instead is FOIL it out. And if you FOIL it out, you eventually get 3 terms. You get an h squared, you get a minus 8h, and you get a plus 16. Right, that's those 3 terms is what you get when you FOIL that, and I'm going to show you that in a minute. And then minus 16 over h. Why am I kind of emphasizing that? Some people make this big mistake. Not quite sure where they pick it up, but you're not the only one if you've done this. Oh, I know how to do these guys. You just square the first guy and square the second guy. So that's what the answer is. You ever seen that mistake? Or maybe you've done it. You know it doesn't work. I know I wish it did work, right? But there is in fact a missing 8h. So it's a good idea to realize that what you're really calculating is a FOIL. Right? Is h minus 4 times itself. And according to FOIL, then you go the first 2, the guy that makes up the f, and it's h times h, so that's h squared. And then the outside one is these 2, and that's h times negative 4, so that's the O of FOIL. And h times negative 4 is negative 4h. And then you do the inside one, which is these 2. And negative 4 times h is negative 4h. So that's the I of FOIL. And then you finish with the L, which is the last one of each, and that's there. And negative 4 times negative 4 is positive 16, and that's your L. And do you see you get the h squared? Those combined to give you negative 8h, and that guy at the end is 16. You convinced that that's the right answer and not that one, right? So back to the question. That's what we got. those two kind of kill each other off. And so what I've done is I've turned the original, which was kind of difficult to factor and kind of difficult to work with, and with a little bit of foiling out and collecting like terms, it's now became this equivalent one. So far, so good. Right, so now we can worry about factor and cancel. Anybody got a suggestion about a factor? Either the, well, really it has to be the top because there's nothing left on the bottom. What would you factor out in this top expression?
Factor the h out.
You factor the h. And isn't that a good sign that it is an h? Because those can cancel. And you're now going to be left with the limit as h tends to 0 of just that guy. And now I can do the brute force by replacing h with 0, combining all the numbers, and the answer is -8. We're looking good at factoring. Right. Then for our last question today, I wasn't going to do this, but I decided I am. I'm going to give you one to try. Yeah. So it is factor and cancel. And who am I going to give you? I want you to factor and cancel. So find the limit using that method. For the limit as x tends to -2 of x squared, take away 2x, take away 8, all over 4x squared plus 7x, take away 2. And you have 3 minutes, actually 2 minutes to do it. Go for it. And if you finished it, while you're waiting for the others, put your last name down in attendance so you know you've done that. And then we'll see if you're right. No pressure, go for it. Got 30 seconds to go. Okay, let's go for it. You can finish it off with me. Right, the top one is a pretty standard, straightforward one. Just got an x squared in it. So I know that's going to be x. I know that's going to be x. Since the number is negative, I know one of them is positive and the other is negative. I just try and find various combinations. And the combination that works is those two. Great. Now, the bottom term is the sneaky one. 4x squared could go two different roads. It could be a 4x and an x, or it could be 2x with another 2x. Now, since I have a clue that the top factors are both x's, that means I understand that the split has to be that. You see, I'm using the top just to make my my job on the bottom a little bit easier, right? It has to be that. And doesn't this guy have to be either x minus 4 or it has to be x plus 2? Agreed? What is the factor in the bottom based on those clues? What's the factors of 4x squared plus 7x minus 2? What do you write?
-1 and +2.
That's what I get. Let's double check it. 4 times 2 gets you 8x, and the middle 2 gets you minus 1x. 8x, take away 1x. Yep, it's the guy. So there were only two choices, weren't there? Right, that guy was either x plus 2 or that guy was x minus 4. Agreed? But, based on what's going on in the top. So I can now cancel. And we are left with an x minus 4 and a 4x minus 1. And at this point, I can now do the brute force part and replace the x with -2. And the top guy gets you -6, and the bottom guy gets you, I believe, -9. But that simplifies down, as you should always do with fractions, to +2/3. Does that look good for those who got it?